Hello, good day to you, students. Um, Today we'll be starting a series on Precalculus II. All right, so this morning we'll be starting with angles, and our learning objectives will be um, looking into converting between degrees and radians, and also finding coterminal angles. Okay, so let us start to talk about um, how to make angles. So now I will be talking about initial and terminal sides. Before now, you know that you can make angles in different ways. For example, what I just did, or something like this, maybe this, something like this, whichever way you want to make angles. But we want to look at a special way of making angles by starting from the initial side here, which lies on the positive x-axis, as you can see in this picture. So we have that, and we have the terminal side on you know, another side. The point is, if we have something like this, now we are saying that the initial side is on the positive x-axis, and the terminal side will be somewhere else. Could be there. It could be somewhere here. That is, we have something like this, or we have something uh, like this. Okay, it does not really matter. What matters is the fact that we are starting with this initial side on the positive x-axis, and you can see in this um, picture. Okay, now how do we draw angles? Well, we draw angles by starting from the initial side and going to whichever way we want to go. For example, 90 degrees, which is starting from this initial side, and the terminal side is on the y-axis. What about 360 degrees? Again, we start on this initial side and we go this way until we make the 360 degree. So it happens that it's on the same side. Both the initial side and the terminal side lies on the same um, place. Okay, now let us look at something much more interesting, the quadrant angle. That is, for 0 degrees, you can see the initial um, side is also the terminal side because it is 0 degrees, right? Um, Nothing fancy here. 90 degree is starting from here and ending here, and so on, 180 to 70, which is 90, 90, 90. So making 270 degrees. The key point is starting on the initial side. Okay, angles that are also not in quadrant form. For example, this. So we start on the initial side and we go this way. This is the terminal. This is the terminal side. This is the terminal side, right? And also, if we go, so you will notice that our angle we're going in counterclockwise direction. For this, we are going in clockwise direction, and we claim that the angle here, let's say this is theta, is a negative angle. So do not forget, when we start from the initial side and we are going, this is the ray for the initial side, and we start from there and we are going in clockwise direction, then we have negative angle. If we go in counterclockwise, then we have positive angle. Okay, moving on. So Origin of measures of angles in degrees. So let us look at um, where measuring angles in degrees came from. Well, in the days, the Babylonian mathematicians count system in base 60. So that is a way, and the idea that a circle could be like divided into 660s. So they came up with 360 degrees for the sum of angles in a circle. That said, they also base their ideas on calendar. There are 365 days in a year, so approximately they say, well, 360 days in a year where 1 degree is equivalent or approximately equal to the 1 day of sun's path. They also consider that because of divisibility, 360 has many factors, so which produces easy fractions. Also, the astronomy used for measuring arcs of stars and planets. So, you will realize from this explanation that coming up with angles in degrees is more of assumption. It's more of assumption. Working in B60 because of calendars, which is 365, uh, astronomy, divisibility. So there is a need for us to work more, um, you know, to be more specific or to coin something much more better than just this assumption. So mathematicians studied circle itself and they came up with the angles in radians. So these angles in radians, they are natural for circles, not based on assumptions, not based on maybe base counting base 60 or calendar of the year. So they studied circle itself. So the radian is based on arc uh, or radius, arc of the circle or the radius of the circle. And it is better for calculus. This radian angle is better for calculus. Um, and also, it yields simpler formulas, just like length of arc equals to r theta, unlike in degrees where we have this. And it has physical meaning by not having no awkward unit conversion. Um, for example, uh, okay, I will talk about that in a bit. So, but for now, just get that there is no awkward unit conversion for angle, radian angle. So let us consider the definition. A radian, or angle in radian, is based on the geometry of the circle. I talked about that by studying the circle itself. Okay, 1 radian. Now, let's see this. 1 radian is the angle made when the arc length equals the radius. Look at this. Consider this circle. So when the arc length, so I will do something like this. So let us say that we have something like this. And we have radius here. So the idea is that, let's say this is our angle. Now, suppose this radius here, which is r, let's say is the same thing as the arc length, which we call s. So if they are the same thing, they're the same thing in length, the radius, the length of the radius is the same thing as uh, the length of the arc, then we claim that the angle here is 1 radian. That is what this definition is saying. 1 radian is the angle made when the arc length equals the radius. That is when s equals to r. So let me just say when s equals to r. Our s is the arc length and our r is the radius. So a full circle, which is 2 pi r, circumference of a circle, is now 2 pi radians, right? It's 2 pi radians because we are claiming that, um, you know, we are claiming that uh, when this is equal to the arc length, that this angle is 1 radian. So in that sense, then we claim that for a circle with circumference 2 pi r, it is also 2 pi radians. So this makes a radian directly connected to the arc length, area, and other circular measurements. So we can see what I was trying to get at clearly here. So in this case, we see that this is the radius, this is the radius, and this is the arc length. So when that s equals to r, this is r, the radius, when s equals to r, then we claim that this angle is 1 radian. And here, the angle we have here is two of of the radius. So that is s in this case is 2 radians, right? It's 2 radians, and so on and so forth here. So let us consider these 2 circles. We'll see that this first circle here, the radius is 2. The radius is 2. And the other one, the radius is 3. So what we observe here is that regardless of the length of the radius, for example, here is 2, so the arc length also is 2, right? And considering the ratio of this S to this R, so which means our angle there is S over R, which is 2 over 2, which is 1. So, um, okay, so considering this, the arc length here is S, um, and the radius is 2. Well, okay, let me take that back. I'm not giving a value to this S. I'm not giving a value to this S, but I'm just saying that this S, this S as is related to this R by comparing theta is S over R, the ratio of the arc length to radius. But what we can see is that when the radius is 2 and when the radius is 3, having different circles, we can see that their angles are still the same. Why? Even if I consider here to be 2, so we'll see that that is 2 over 2, which is 1. So, and also theta, when s over r, so when it is 3, so it is still what? 1. So we can see the ratio of s to r is 1. So what that means is that the most important thing here is that that angle stays the same. It is 45 degrees when the radius is 2. It is 45 degrees when the radius is 3. So it does not really matter what the radius is. The angle is what matters. So because, or let me say the angle is the same. That's another way to quote what I was trying to get at. The angle stays the same, even though we have different measure of the radius. Okay, so using radians, because a radian measurement is the ratio of 2 lengths, like I've explained, S to R, it is unitless. It is unitless. For example, if length of R is 2 centimeter, as we had the other time, and this is 2 centimeter, centimeter will take care of centimeter, and then it is unitless. No unit again, because that is going to give you 1. So just call it 1 radian. Okay. Considering the most basic case, let us consider the most basic case, the unit circle. A unit circle is a circle with radius 1. Please do not forget that a unit circle has a radius 1. So we know that one rotation equals 360 for a unit circle. Let's say this, let's say from here to here, uh, from here to here is 1, right? Is 1. So what we are claiming is that if we start here and go this way, which makes it 360 degrees, right? Um, so let's keep in mind the radius is 1. Radius is 1. So in that case, one full rotation is 360 degrees. We do know that one full rotation in degrees, it is 360. Then in radian, remember that circumference of a circle is 2 pi r, which is also the same thing as 360 degrees. Okay, now if this r, if this r is 1 in the unit circle, the radius is 1. So we have 2 pi, so that is radian. Uh, so instead of 360 degrees in terms of degrees, so we can also call it 2 pi radian. So half of a rotation, that would be half of 2 pi, which is pi, or half of 360, which is 180. 1/4 of that, 90 degrees, pi over 2. So the quick thing to learn here is that one full rotation, one full rotation is 360 degrees in the degree world, which is the same thing as 2 pi radian. So you can do whatever you like. 1/2 of a full rotation, 1/4 of a full rotation, 1/3 of a full rotation. You can move back and forth together. Okay. You will still going to be, you will be seeing a lot of something like this as we progress in this class. So this is just showing you when our angle is 30 degrees in the degree world, it is also pi over 6 in the radian world. When it is 45 degrees, it is pi over 4. How did we get this? Um, we'll keep studying this as we go. Okay, so like I said, we will return to this kind of chart or circle. It is special in what we are going to be doing this class. So example, find the radian measure. Read it very well. Radian measure, we want to find radian measure of 1/3 of a full rotation. Remember that one full rotation in radian form, one full rotation, we claim that it is 2 pi radian, one full rotation. Now, one third of a full rotation will give us 1/3 of 2 pi radian. So, which is 2 pi over 3 radian. Done. So pause this video and try to find the radian measure of 3/4 of a full rotation. Okay, if you pause this video, you will realize that you just need to do 3/4 or 2 pi. So which is 3/4 times 2 pi radian, and that is, let's see, that is 2 here, 2 here, 2, 1. So that is, technically, we are having 3 pi over 2 radian. So that is that. Now let us walk about how to convert between radians and degrees. Since we talked about radian angles being very, very useful in mathematics or to mathematicians. So we should be able to convert between the two, from radians to degree and from degrees to radian. So in that sense, let us use proportion. Look at something like this. This is circle, this is circle. Now, if I have something like this, and I call this theta, do this theta. Now, let me say this is in the degree world, and this is in the radian world. Now, this angle here is just part of 360 degree, which is equivalent to this angle here is also to 2 pi. I hope that makes sense to you. This is a part, theta divided by 360 out of 360. This angle out of 360 out of everything. This is also theta out of 2 pi out of everything. So what I will do is to say this is degree and this is radian. Now, looking at that very well, you can see that I can reduce this by multiplying both sides by 2. So which leaves us with here 180 here. So we do have that theta, the angle in degrees is to 180 as the angle in radian is 2 pi. So this is the formula you need in converting from radians to degree or from degree to the radian. Okay, convert each radian measure to degree. So this is pi over 6 radian. How do we convert it to degree? Just use what we have. Our angle in terms of degree is to 180 as our angle in terms of radian is to pi. Simple. Nothing to memorize there. So since we are looking for this, so this, our angle in degrees over 180 equals to our angle in radians, that is pi over 6. So divided by this pi here. Okay. Now, solving for that, we find that so we can actually multiply both sides by 180 to get rid of that 180 here. So we do have that our angle in degree is, if you compute this very well, our angle in degrees is 30 degrees. The same thing with 3 radians, because it is unitless, you can say 3 or just 3 radians, right? Okay. But if you are talking about angle, you need to put degrees there every time. So, but this is radian, so 3 is fine. Or you write 3 radian. Okay, again, I'm going to use this formula here. So our angle in degrees over 180 equals to our angle in radian is 3 over pi. So again, I can multiply both sides by 180 degrees so that I can get rid of 180 degrees. So that is theta in degrees is 540 over pi degrees. So you don't need to do anything to it, just leave it this way. And lastly, we want to convert 15 degrees to radian. So again, use that formula. Our angle in degree is to 180 as our angle in radian is to pi. So, so in that sense, we know that our angle is in 15 degree, I mean in degrees rather. So to 180 as this, interesting. So as this is to pi. So we are looking for angle in radian. So I want to get rid of what I have here, pi. So to do that, I only need to multiply both sides by pi, multiply both sides by pi. So I do have 15 here, 1, 15 here, 12. So that is pi over 12 equals to my angle in radian. So conclusively, angle in radian is pi over 12 radians. Okay, I hope that makes sense to you. So this is some exercise for you to go about. Convert -3/4 pi radians to degrees. Again, the you only need to use the idea we had earlier. So pause this video and try to work it out. Okay, I assume you paused the video to work on it. So this is something you should be having. Our angle in degrees is to 180. So nothing to memorize. Look at that. Our angle in radian is to pi. So we are looking for our angle in degrees. So that is in radians, we have it to be -3 4 pi over pi. So again, I can multiply it by 180 and I can multiply it by 180 degrees. So what we do have is our angle in degrees equals to, maybe this can take care of this. So that is -3/4 times 180 degrees. So 4 here 1, 4 here, that is 4 remain 2, that is 5. So that is -3 times 45. So that is minus. So our angle in degrees is minus, that is 135 degrees. You have to put this degree there because if you just write 135, it means you are saying 135 radians. So to differentiate, you have to put degree. All right, moving on. Also pause this video to convert 126 degree to radians. Well, we do know that our angle in degree is to 180 as our angle in radian is 2 pi. So just substitute. We know this to be 126 degree is to 180, which is our angle in radian is 2 pi. So we want to get rid of pi here. So multiply by pi, because I'm looking for this. Therefore, our angle in radians is, so this takes care of this. So we are only left with pi, and we'll do this one. So that is 126 over 180 pi equals to angle in radians. So, well, we can still reduce this. Let's see. Maybe we reduce it. Let's say 6 here. That is 2, 1. 6 here. That is 3, 0. We can say 3 here, 7. 3 here, 10. Which implies that our angle in radian is 7 over 10 pi radian. We do not need a calculator for that. Okay, now the next thing we want to look into is finding coterminal angles. What are coterminal angles? Coterminal angles are two angles in standard position. You remember what standard position is? So these two angles should be in their standard position, or should be in standard position. Now, here's the catch. They have the same terminal side. For example, look at this. Let's say we have something starting here. Then let's say the angle is like this. So now from here to here, let's call this 140 degrees, right? As I have it here. Now, this is the initial side, and this is the terminal side, right? Now, if I do this, let's say I move this way from here now, remember we always start from the initial side. So I move this way. Now, what is this angle? Well, this is reading from here back to here. So here is 90. So to get 140, so here would be 70, I believe. That is from here to here is 70. So is that true? 140, 140. So this is 90. Oh, sorry. Okay. So this is 90. So this will be 50 degrees. And here will be 40 degrees. Now, if we move this way, this is 90. This is another 90, making 180 plus 40. That is 220. But remember, because we are going in a clockwise direction, that is a negative angle. So we have negative 220 degrees. Now, the key point is that look at these two angles. Here to here is 140 degree. Here, here to here is negative 220 degrees. So we say 140 and negative 220 degrees are coterminal, angles. Also, because they both have the same terminal side. Now, what about something like this? Something like this. Uh, something like this. Let's say I'm starting from here, as I should. Then I move this way. It is more than one. I move again. Oh no, I don't want this thing doing that. Okay, so I move from here. So let me just stop here. This is my terminal side, my initial side, my terminal side. Okay, now what if my claim is that if I start here and move here, that would be the angle I'm having here will be coterminal with the first one. Now, what if we have something like this? What if we have something like this? Here, I move like this. I go here and this. Boom. Whatever I have there is still coterminal with 140 degrees. What do I mean? Again, I start from the initial side. I move a full circle. But instead of stopping it, then I move here. So that is, I'm adding a full circle to that 140. Now they have the same terminal side. So we say that angle and, for example, 360 degrees plus 140. So that is 40, 40, 100, so 0, 0, 5. So we say they are co-terminal. And also, one question you can also ask is, what if it is the other way around? Well, I can also do something like this from here. Instead of stopping, I go again before I stop, right? So I have also found another angle that is coterminal with 140 degrees. So in general, um, given an angle greater than 360 degrees, if your angle is greater than 360 degrees, that is, it is more than one full rotation, how do we find a coterminal that is between 0 and 360? All you need to do is to subtract 360 degrees from the given angle. If the result is still greater than 360, subtract 360 again, right? Until you fall within this range. So we claim that the resulting angle is coterminal with the original angle. What if your angle is in radian? If it is in radian, then instead of using 360, you use 2 pi. So that is just that. Okay, let's see this problem. find the least positive angle that is coterminal with angle measuring 800 degrees. Let me see. I don't want this video to be uh, too long. Let me see. Okay. Uh, all right. Okay. Um, find the least positive angle. The least positive, the smallest positive angle that is coterminal with an angle measuring 800 degrees. Now, what does that mean? Look at this, 800. How do we show 800 angle that is 800? Well, look at this. It means we have something like this. Boom, boom. That is 360. We go again. Now let me do this. So we move here, 360. We go again. Complete again, 720. Ah, 720, right? I need 80 more. So maybe if I go, it will be somewhere here, right? So here is 80 degree. No, 800 degrees. That is our claim. 360, 720, then plus 80. We have 800 degrees. Now, the question is find the least possible positive angle, the least positive angle that is coterminal with 800 degrees. So we will see that from here to here, from here to here is 80 degrees. So we will claim that 80 degree is coterminal, coterminal with 800 degrees. Yes, so that is our claim. Another way to do that is how, if we have angle that is 800 degrees and we want a coterminal that is inside a single rotation, 0 and 360 degrees, all what you need to do is from 800 degrees subtract 360. What do we have? We have 0, we have 4, we have 4. Now, this is still not in this range. It is still bigger than 360. So what we do is go ahead again and subtract 360 degrees. What do we have? 0, that is 14, that is 80 degrees. So that is another way to do. So we know that 80 degrees is coterminal with with 800 degrees, or it is the least positive angle that is coterminal with an angle measuring 800 degrees. So 440 is also coterminal, right? With 800, but because it is still outside our range, that is why we go one more time. Example, show the angle with measure negative 45 degree on a circle and then find a positive coterminal angle such that that angle is between 0 and 360 degrees. Well, negative 45. Remember, negative, to draw a negative angle, we go clockwise now. So, meaning from initial side, so we go this way. Let's say this is, yeah, so this is negative 45 degrees. Now, the question is, we've already shown that angle now. Now, find a positive coterminal. For us to get positive, we need to go counterclockwise, right? So, we see that if I go this way and I stop here, now they have the same terminal point. So that angle is coterminal with negative 45. But let's see what it is. Here to here is 90. Here to here is 90. Here to here is 90. That is 270. 270 degrees plus. Now, if here to here is 45, here to here is also 45. So we just need to add that 45 so that we can get to this point. So that is 315 degrees. That implies that 315 degrees and negative 45 degrees are coterminal. I hope this is making sense to you guys. They are coterminal. They are coterminal angles. Okay. Or another way, or since this is negative, I want it to be positive, 0 and 360. So just add 360 to it. Just add 360 degrees. Your answer is 315 degrees. So these and these will be coterminal. So it's as simple as that. Okay. Now find an angle. Another example. Another example. Find an angle. We call it beta. That is coterminal with 19 pi over 4. That is coterminal with 19 pi over 4. So in this sense, so in this sense, we want to find an angle that is coterminal, that is having the same terminal line with 19 pi over 4. Now, looking at 19 pi over 4, just pause this video and think for a while. What will you do? This is more than 2 pi. 19 divided by 4 is 4 and something, right? Okay. So meaning that it is more than 2 pi, more than one full rotation. So what you can do is, if you want to find an angle that is between 0 and 2 pi, that is coterminal with that, just subtract 2 pi. Subtract 2 pi from that first. And what do we have? I can say this is 19 pi over 4 minus, I can rewrite this as 8 pi over 4. It is still 2 pi, right? It is still 2 pi. I just want to be sure that they have the same denominator. So which is 11 pi over 4. The question is 11 pi over 4 within 0 and 2 pi? Let's see. 11 divided by 4, that is more than 2. More than 2. So we need to go again and uh, let me do it here. So we need to go again and say 11 pi over 4. We need to subtract 2 pi again. So again, I can write it as 11 pi over 4 minus 8 pi over 4. So which is 3 pi over 4. Now, what about this? 3 divided by 4, that is not up to 1, right? Oh, that means we are now between 0 and 2 pi. So our claim is that 3 pi over 4 is, let me say, and 19 pi over 4 are coterminal. I hope this is clear to you very well. So this is something for you to try out. Find an angle that is coterminal with negative 17 pi over 6, where your angle beta is between 0 and 2 pi. That is just in one full cycle. You want your answer in just one full cycle. Well, all you need to do in this case is, you want to think of something? What do? You add 2 pi. Here we subtracted 2 pi because what we have here is positive. So we need to subtract, oh, sorry, I raised my hand here. Okay, so What I can do there is to let's see, subtract 2 pi because 19 pi over 4 is more than 2 pi. It is more than one full cycle, so I need to subtract so that I will be able to jump into that. For negative, I need to add 2 pi. So if we do the same thing, what do you have? So just keep adding 2 pi until you fall within one full cycle, that is between 0 and 2 pi. Between 0 and 2 pi. Okay, now unit cycle. Let us start getting into this Precalculus II uh, gradually. Um, so we want to look at sine and cosine functions. How do we come about this? How do we develop sine and cosine functions? That is what we want to look at right now. And the first thing we will look at is the unit circle. Remember, we defined a unit circle as that circle that is having radius 1. So in this case, we will consider that the origin is at 0, 0. That is, you have something like this. This is the origin, 0, 0. So this is our unit circle with the radius being 1, r equals to 1. So we say this is a unit circle. The center is at the origin. The center is at the origin, and the radius is 1. In a unit circle, the length of the intercepted arc is equal to the radial measure of the central angle T. I was explaining this the other time. So that arc, let's see. So in a unit circle, the length of the intercepted arc is equal to the radial measure of the central angle T. So if I have something like this, let's say here is angle theta. So from here to here, if I pick that to be S, which is going to be 1 as well, right? So like I discussed earlier, so that angle is the ratio of S to R, which is in this case, you can say R over R or S over S, so which is 1. Okay, now let us study something. On our unit circle, you know what a unit circle is now. So now a unit circle, I want to define a point. There is a point on that unit circle. There are several points on it. So I pick a point and I call it X and Y. This X, this Y. Call it that. Now, then I define that Y to be sine of T, and I define that X to be cosine of T. You remember, you know what T is? That is the radian angle, right? The radian angle. Okay, so our claim, please, is that this X is the cosine of T, and this Y is sine of T. Okay, now formally, if T is a real number and a point X, Y on the unit circle corresponds to an angle of T, you know what that angle T is, right? Then that is that angle T. We just have it there. Let me just make sure everybody is following. I used theta for it the other time. Yeah, I'm using T. It is the same. Nothing uh, to be confused about. The only thing you need to understand is that we are claiming that the radius here is 1. So this arc length is also what? Is also 1. So we say that angle T or theta, whichever case it is a radian angle. And we are now defining it that if we pick a point here and we call it X, Y, Then we say this x is the cosine of that angle, and this is the sine of that angle. That is the definition. We just define that, okay? We just define that, trying to develop some concept. So what I just said is what I have in this place. We are going to be making use of something like this. Some of you might have seen, the unit circle before. This is not a complete unit circle, but this is showing you, this is angle 30 degrees. It is the same thing as pi over 6. Okay. You can just convert vice versa from degrees to radian angle, or from radian to degree. So now let us look at something. Point P. We have a point P. We have a point P with coordinates x, y. Is a point on the unit circle. Is a point on the unit circle corresponding to an angle of t as shown below. Okay, this is the figure. Find cosine of t and sine of t. What do we have? Everything has been drawn for us. From here to here is root 3 over 2, which is y. From here to here is 1/2. How did you get this? Don't worry. For now, we are just using it. It's 1/2. So we say x is 1/2, y is root 3 over 2. So the question is to find cosine of t, sine of t. Remember that our x is the cosine of t and our y is sine of t. So that implies that cosine of t is this x, which is 1/2. And sine of t is this one, this y, this. So that is root 3 over 2. The most important thing here is just know that your x, the first component, the x is the sine of that radian angle, and that y is, the cosine. The cosine of that radian angle, and y is the sine of that radian angle. That is the most important thing to learn here. Okay, why don't you pause this video and try this by yourself? Again, a certain angle corresponds to a point on the unit circle. This is a point on the unit circle. Again, this is x, this is y. Find cosine of t, find sine of t. So you should be able to know what cosine of t is and what sine of t is. Okay, well, it turns out that the cosine of t is negative root 2 over 2, and the other one is root 2 over 2, because this is x and this is y. And remember, our x is cosine of t, and our y is sine of t. Okay, find cosine of 90 degrees and sine of 90 degrees. We don't have any picture of that, but we do know something. Let us go back. Remember our unit circle that we are studying? The radius, that is from here, please pay close attention, from here to here is 1. Radius is 1. So now, here, let me do this. Now, it means that the x on the x, right? So it means this is 0. Sorry, this is a 1. That is, here is 1. That is, x is 1. But y is 0 because it is horizontal here, right? Okay, so x is 1, because that radius is 1. So x is 1 and y is 0. What about here? It means x is 0, y is 1. What about this point here? X is -1 because it is the negative x-axis. So here, -1 and y is 0. And what about here? So this point, x is 0 and y is -1, right? Because this is negative y-axis here, -1. Okay, now, having done that, cosine of 90 degrees is, let's see, this is 90 degrees, right? This is 90 degrees. Now, this is x, this is y. Now, what is cosine of 90 degrees? Cosine is the x component. So that means it is 0. And sine of 90 degrees, the sine, which is for the y component, is 1. So if you try this in your calculator, cosine of 90 will give you 0. Sine of 90 will give you 1. Find cosine and sine of the angle pi. What of pi? Remember what pi is? The angle here is 0. So moving to this place, that is pi over 2, to this place, that is pi. Yeah. So here is pi. So what is cosine of pi? Cosine of pi. This is the point, the terminal point. X, y. X is for cosine. So what is cosine of pi? You see. What is uh, sine of pi? What is sine of pi? That is the y component of that. So recall that. Now, let us study something interesting, the Pythagorean identity. Now, recall that equation of a circle is given by x squared plus y squared equals to r squared. Maybe you are not familiar with that, but look at something. From our unit circle, remember we are studying unit circle. So I have this, they have this, right? So I call this part, I call this point P with components or coordinates x, comma, y, right? Now, meaning my y is this, and from here to here is my x, right? Now, here is the radius. If you remember Pythagoras theorem, where we have a right triangle like this, here is x, here is y, here is r. This can be related as x as x squared plus y squared equals to r squared, which some of you call a squared plus b squared equals to c squared. So the same thing is what is happening right here. So it turns out that this is the equation of a circle with center at the origin. In this case, the center is at the origin, right? Okay. Now, if it's a unit circle, we know that a unit circle has radius 1. So we have x squared plus y squared equals to 1 squared, which is x squared plus y squared equals to 1. Then we have equation of a unit circle. But in general, this is equation of a circle with the center at the origin. Do not forget that. Now, maybe you have been thinking about this, but we know that this x is cosine of t, and this y is sine of t, right? We can put square here so that because it is x squared, so that is cosine of t squared and sine of t squared. Then our claim is that if we add them together, it should be 1. So this is what we call Pythagorean identity. Cosine squared t plus sine squared t of the radian angle is 1. That's a very useful result in mathematics. Do not forget that, please. Okay, let us solve some problems. Finding a cosine from a sine or a sine from a cosine. What does that mean? If sine of some angle is 3/7, you find the sine of some angle and it is 3/7. And that angle is in second quadrant or is having terminal side in the second quadrant. Something like this. Uh, right? So maybe this angle. So the terminal side is in the second quadrant. Now, find cosine of t. Remember, this is the terminal point where we have cosine of t, sine of t, or x comma y. Now we have been given these to be 3/7. Now we need to find cosine of t. We do know one thing that brings the two together, and that is the Pythagorean identity. I start by saying we know that x squared plus y squared equals to um, 1, 1, right? We are dealing with unit circles, so we know that the radius is 1. So 1, 1 squared, which is 1. Now, we do know that cosine squared of t plus sine squared of t in terms of trig identity now equals to 1. We just saw that earlier. Now, sine of t is 3/7. So sine of t is 3/7. We can square that because this is squared. So cosine squared of t equals to 1, right? Now, cosine squared of t equals to 1 minus 3/7 all squared, which is 1 minus 9/49. So that is cosine squared of t. So cosine squared of t is, if you do your maths here over 1 and you should be having 40/49. Now, we are looking for cosine of t, not cosine squared of t. So we can take square root on both sides, square root both sides. So we have cosine of t equals to, and when you are taking square root, remember, this becomes plus or minus. So we have something like this. I can rewrite this as root 4 times 10 over the square root of 49 is 7. So I can do that. So that is plus or minus 2 root 10 divided by 7. Right? Square root of 4 is 2. So that is 2 root 10. Because square root of 10, we don't want decimal. So just leave it out. Divided by 7. We need to do one more thing. What is the sign? Is it positive? Is it negative? Well, look at it in the second quadrant. In the second quadrant here, our x value is negative. X here is negative. Y here is positive, right? So since it is here, it means the x value is going to be negative. Therefore, using that notion, we conclude that our cosine of t is negative 2 root 10 divided by 7. Answer. So that means if we have some angle behaving this way. It's in the second quadrant, and the sign is 3/7. It means that the cosine is negative 2 root 10 over 7. So that is that. So you can pause this video and solve this by yourself. Cosine of angle T is 24 over 25, and T is in the fourth quadrant. Find sine of T. We do the same thing. So pause this video and solve that. And in the end, you should be having these results that I'm about to write here. I will not talk, so just make sense with me. I'm assuming that you pause the video to work it out. So now let's see what you should have. 24 times 24. Well, apparently you should know this often. So that is 16, that's 96, this is 8, this is 4. So 576, 576 over 625. So if you carry out this fraction, you should have that. You can square root both sides because you're looking for uh, sine of t. So if you do that, then you introduce plus or minus. Okay, now remember, we have two answers, plus or minus 7 over 25. But we have a clue that our angle is in the fourth quadrant. Let us see the behavior in the fourth quadrant here. Fourth quadrant. X is positive. X is positive. Y is negative. Y is negative. X is positive. So, meaning our uh, sine of t is, since y is negative, negative 7 over 25. Hopefully that is what you got. If not, just pause the video, go back to this example, uh, then you go again. You solve it again. Now let us look at this example. Does this point, does it lie on the unit circle? How do we know that a point lie on the unit circle? We know that this is x, we know that this is y, or you call it cosine of angle t or sine of angle t. We know that if I add the square of both components together, it must give me 1. It must give me 1. So let us see, maybe that is the case. I do know this. Our x is, so let us check. Our x is 3/5. Let us square that, plus our y is 4/5. 4/5. 4/5. Let us square that. What do we have? We have 9/25 plus 16/25. If you solve that, that is 25/25, which is 1. Oh, it is true. So it implies that the points 3/5, 4/5 lies on the unit circle. Put differently, square each component and add together. The sum should give you 1. That is the Pythagorean identity. So that is how to check if a point is on the unit circle. The point P is on the unit circle. Look at it. We have been told that the point P is on the unit circle. If the x coordinate of P is 1/4, what are the possible values of y coordinates? Since that point P is on the unit circle, we know that x squared plus y squared is 1. We know that. And we do know that the x component is 1/4. So if I square that and add it to y squared, it must give me 1. So in that sense, I have 1/16 plus y squared equals to 1. So y squared equals to 1 minus 1/16. And that is 15/16. Therefore, I can square root both sides. And when I do that, I need to introduce plus or minus here. So this square root will take care of this. We have y equals to plus or minus square root of 15/4. Right? So these are the candidates. In this case, I don't know which one is what because I don't even know. Maybe the point P is in quadrant 1 or 2 or 3 or 4. So, but the question is saying what are the possible values? So we have 2 root 15/4 or negative root 15/4. So those are the possible values. Okay, I will just stop here for now, and we will continue from there in our next class. All right. So thank you guys, and I hope you enjoyed this video. Bye bye.